Good morning. Now we are discussing a few concepts in solid state physics, under which we study Introduction to Crystal Systems. The study of geometric form and other physical properties of the crystalline solids with the help of X-rays, with the help of electron beams, and with the help of neutron beams together constitute what is known as crystallography. In crystallography, with the aid of X-rays, electron beams, and neutron beams, we study the geometric form as well as the physical properties of the substance which is under consideration. The solids are classified into three different categories. One is the amorphous solids, the polycrystalline solids, and the single crystals. In case of the amorphous solids, even though the atoms as well as the molecules are strongly bound to one another, there is no regularity in the arrangement. The atoms as well as the molecules are not regularly arranged. They are not periodically placed with reference to one another, even though they are strongly bound to one another in case of these amorphous solids. And in crystalline solids, the atoms, the ions, or the molecules will have a regular and ordered arrangement of these atoms or ions or molecules, and they are arranged in a regular three-dimensional pattern. But in case of real crystals, we can see imperfections of different types. And these imperfections may be due to the missing atoms. The imperfections are called defects. And the defects are otherwise known as the imperfections of real crystals, may be due to the missing atoms and may be due to the atoms out of the place or the displacement of atoms from its regular positions, as well as the irregularities in the spacing of rows or otherwise columns, and also the presence of impurities play a major role on the physical properties of these crystals, and hence these defects play major role on the physical properties of crystals. We have many number of imperfections or defects in case of real crystals. Hence, the study of geometry of the crystal will help us to understand how the solid behaved with reference to the mechanical property, with reference to the metallurgical property, electrical property, magnetic property, as well as the optical property. And these properties, by studying the geometry of the crystal, one can have the knowledge of these properties of the crystal. And these imperfections, or otherwise known as defects in the crystal, can be controlled by suitably altering to improve the selected properties of the material. Now coming to the crystal structure, we are studying space lattice. Crystal structure of a solid refers to the size of the solid, the shape of the solid, as well as the arrangement of atoms within the solid. This together is known as crystal structure. And these crystals are made up of regular, periodic, three-dimensional pattern of atoms. The atoms in a crystal are arranged in a regular, periodic, three-dimensional array, and they are arranged in space and which is called the crystal structure. And the atoms in the crystal structure can be represented by dots or otherwise known as points. If the atoms are, or in other words, the dots or points are arranged in regular periodic three-dimensional pattern, then the resulting arrangement of these points is called crystal lattice or space lattice, as shown in these two figures. This is two-dimensional, and this is the three-dimensional arrangement of points in space, which is called crystal lattice or otherwise space lattice. A space lattice is defined as an infinite array of points. Points are nothing but the atoms or molecules or ions, which are arranged in regular periodic three-dimensional form in space such that each point in the lattice has exactly identical surroundings. If you consider a point and that point is surrounded by the identical points, maybe in two-dimensional or maybe in three dimensions, and these points are called lattice points or lattice sites. Using the network of lines, so you can see lines in this figure, lattice points may be joined. Such lines are called lattice lines or lattice directions. A plane containing lattice points is called lattice plane or the atomic plane. Here we have only single plane, and so such a plane containing lattice points is called lattice plane or simply the atomic plane. Thank you.